Hello and welcome to this sixth and last lecture on data collection and pre-processing in this course, Mastering Artificial Intelligence. So in this lecture also, we will continue to talk about the example of that sentiment analysis that we started talking in the last lecture and illustrate how did the company gather relevant data from various sources, ensure its quality, and pre-processed it to make it suitable for analysis and modeling. So the thing that they did was the last thing after having talked about bagger words and TFDF, TFIDF use, we will look at word embeddings. So how pre-trained word embeddings like glow to wake, word to wake and glow wake was used to represent words as dense vector in the continuous vector space. So these two techniques were used to represent words as dense, as what is called the dense vectors in continuous space, which basically means closely defined words together in a continuous sentence formation kind of a thing. So in this sentiment analysis project that was done, and these pre-trained word embeddings captured semantic relationship, the meaningful relationship, relationship by way of the meaning between the words based on their distributional property in the large set of text data, right? So this is how the word to vec and glowvac embeddings were used in this example. Let's take a look at the steps that they followed. They first pre-trained the word to vec and glowvac embeddings that were available as pre-trained models that map to words to these dense vectors in continuous vector space. These embeddings were trained on large text data to capture semantic relationship between the words in the way that the computer understood. Then each word in the vocabulary of the sentence analysis was mapped to its corresponding pre-trained word-to-vec and glow-vec embedding vector. And if the word in the data set was not present in the pre-trained word embeddings, it was represented by a zero vector or replaced with a special token. Then they constructed sentence embedding to represent a review of or document as a dense vector. They aggregated the word embeddings of all the words in the review. Common aggregation methods included averaging the word embeddings or using more sophisticated techniques like weighted average based on TF-IDF scores. So that's how it was done. So let's look at our example and see how this looked like. So as you can remember, we had the three reviews, the following reviews in a data set in the example. The product is great and works well. I am satisfied with my purchase, and the product is terrible and doesn't work. These were the three reviews that we have been working on. So what they did was they tokenized each review with individual words and mapped each word to its corresponding pre-trained word-to-vec or glow-vec embedding vector. And then they aggregated the word embeddings for each review to obtain a dense vector representation of the review in the continuous vector space of the pre-trained embeddings, right? So how did this dense vector representation obtained from this exercise look in the above example? So in the above example, we had pre-trained word-to-vec embeddings available for the words in the review. Each word in the vocabulary was mapped to a dense vector in the continuous vector space based on its semantic meaning captured from the large set of data for training on the word-to-vec model. And this is how as you see below, this is how the dense vector representation obtained from this software look like for these example reviews. And these were like a product had a vector of 0.2 minus 0.3, 0.1 dash 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 like this one for. And these are better understood by the computers and the machine learning languages. It's not human language as such. So now, having looked at these, what they look like, now let us represent each review as a what we have been calling the dense vector by averaging the word-to-vec embedding of all the words in that review. So we have each word, how was the word embedding look like, and now we can use that to obtain the dense vector for each review. Now here we are assuming that the words not present in the pre-trained embeddings were represented by zero vectors. Now the first one was review one, the product is great and works well. And in that case, the average word to vec embeddings were like these. The product, the was left out, the product, great, works well. These were the four keywords, right? And you have their word to vec embeddings here. And this resulted in a dense vector representation for review one, as I'm going to show you now. So it kind of worked on this basis, and this is how this whole thing worked out. So averaging method was used, and if you see the first part of the vector was average of the first part of the vector of each of these words, 0.2 plus 0.5, 0.3 and 0.4. So that's how it was calculated, and it was average over these, and that is what the dense vector for the review F1 looked like. Similarly, you could quickly see for review 2, I am satisfied with my purchase, what it could look like. Again, the average word to vec embeddings relevant were satisfied and purchased 2 words, and this resulted in a dense vector representation of the review 2, 0.1 plus 0.2. You see each column being added, divided by 2, average here, and that's what the review 2 dense vector representation looked like. Third, you will get a hang of by now. So this product is terrible and does not work. Again, had 5 words. Each had its own word embeddings, and added them up. It came to the dense vector representation of word 3. So you get an idea of how this process was done. Right. So the dense vector representation obtained from the pre-trained word embeddings was used as an input uh, for feature for the machine learning language models in the sentiment analysis test. Now these word embeddings captured, semantic similarities between words, allowing the model to learn meaningful representations of the text data and make accurate prediction. So this is how these dense vector representation of the 3 reviews were used in the model. Using these pre-trained word embeddings like word2vec and gvec provided a way to represent words as dense vectors in a continuous vector space of the computers with machine learning models, and they captured semantic relationship between the words and enabled effective modeling of the text data in the sentiment analysis project. The final step in this example is about exploratory data analysis, where the team explored the pre-processed data to gain insights and understand the distribution of sentiment labels, word frequencies, and other relevant patterns. And the final thing in this data analysis was to visualize the data using techniques like word cloud, as you see here, frequency distribution of the words, and sentiment diagrams. So that's what was the visualization about. So by following these steps, the team gathered the relevant data from various sources, ensured its quality, and pre-processed it to make it suitable for sentiment analysis of the AI project focused on customer review. And these pre-processed data was then used to train the machine learning models for sentiment classification or to extract insights from the customer feedback. So what is next? So having looked at data collection and pre-processing, we will now get into the core of algorithm selection and development in the next set of lectures. So thank you so much for watching this 6th and the last data collection and pre-processing lecture in this course, Master in Artificial Intelligence. I hope you're continuing to learn new things, continuing to enjoy. And I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions. And also download the PDF file to take a look at anything of something that could be of more interest to you to spend time on.